We just talked about current coming through a current carrying conductor or a wire in the opposite direction causes repulsion, and the same direction causes attraction. So in this case, and in this case of current carrying conductors having their electrons flowing in the same direction in conventional current flow, these lines are going to be pulled together. Why are we talking about that? Why is that important? Well, the fact that these pull together is literally the basis for the definition of an amp. This magnetic attraction is the basis for the definition of the ampere that we know. So let's look at what an amp is. An amp is the constant current that produces a force of 2 times 10 to the negative 7 newtons per meter when flowing through two straight parallel conductors of infinite length and negligible cross section. They happen to be 1 meter apart in a vacuum. Let's look back at these diagrams that we have picked through so carefully and we understand. An amp is the constant current. So where is our current? Let's see where our current is. An amp is the constant current. We have current flowing through here. 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 We're not talking about this case of repulsion. It is the constant, it is that current that is highlighted in pink that produces a force when it flows through two straight parallel conductors. Two straight parallel conductors, two straight parallel conductors. They have length infinity. They have infinite length conductors. An amp is the constant current that produces a force of 2 times 10 to the negative 7 newtons per meter. Well, newtons is a force, right? A newton is a kilogram meter per second squared. A newton is a kilogram meter per second squared. A newton is a force. A newton is a force. That is going to produce that many forces per meter when it that many newtons in each meter, which will give us a force when it flows through two straight parallel conductors, which it is, of infinite length and negligible cross section. That means they have to be really tiny. It looks like they are. They happen to be 1 meter apart. So from here to here is 1 meter. And they happen to be sitting in a vacuum, which is a lack of air. So this is the setup that is the definition of an amp. And you might be thinking, oh, that's a coincidence that this is actually an amp. Well, it's not a coincidence because humans made up amp and they made up what is a 1 amp. Let's choose 1 amp to be when this amount of force is produced. So now I need to sort of clean things up a little bit so that I can show the force. And so what the definition of the amp is it's the force that got produced here, because when these green bands try to be as small as possible, these flux lines try to get as small as possible, that produces a force. I like to draw forces like this. This is a vector. It just means that it also has a direction. So there's the force that is created. And how big is that force? We say, let's call the current equal to 1 amp when we can measure, in this situation here, when we can measure the force equal to a certain number of newtons per meter. All right, and it's 2 times 10 to the negative 7 newtons per each meter. So when we get to 2 times 10 to the negative 7 newtons on this substance that's a meter, on these two things that are a meter apart, we measure this, we measure this, we measure this, we measure this, we measure this. Once we get up to this amount, we say, hey, let's call that an amp. So that's a made up definition of an amp. So now a lot of people know what, and a lot of people have used an amp before. They know what an amp is and that how it relates to electricity. That's how an amp relates to magnetism. That is the formal definition of an amp. Two current carrying conductors, electricity moving in the same direction, lines of flux unite, which make that line of flux pull these two current carrying conductors towards each other with a force of 2 times 10 to the negative 7 newtons in their distance of 1 meter in a vacuum. And I think that is a whole definition. Oh, and they are of infinite length. And they are so tiny that they are a negligible cross section. Once that happens, we say, oh, that's an amp. Cool.